So in terms of photo editing benchmarks over here, first of all, let's have a look at the Photoshop benchmark over here. As you can see on the right side over here, I've got my calculated benchmarks over here, and we've done the average over here, and we're roughly scoring 1170 on the Photoshop over here. And then looking on my like benchmark database over here, I can see that we're scoring roughly around here, which is like 12600K over here is slightly lower. That's best bang for buck. That's this white PC that we built it over there with 3060 over there, so much better GPU over there. But
Lauri,
yeah,
you're really saying over there, lords.
So I'm super excited to share this minimalistic looking PC build and benchmark and overview and review with you, especially if you are a photographer, because we don't talk a lot about PCs for photographers, but this one over here is kind of optimized and created for photographers. But why is this one specifically for photographers? Well, in this video you're going to find out as we're building this, and I'm going to talk you through the parts and why these parts and why these work best for photographers. If you're doing other things, the kind of balance of different components might be somewhere else, but this is especially optimized for photographers. So let's build this thing, and in the end of the video we're going to talk about a little bit of the overview of this, run some benchmarks, and then conclude this video.
Looking for a cheap way to license your Windows? Check out Whokeys through the links in the video description. Make sure to use the code TN20 to get a 30% off. Paste the license to the activation settings and you're all done. This license is for Windows 10, but you can upgrade it to Windows 11 for free. They also offer Microsoft Office 19 license. Use the same code TN20 to get a 30% off. Check out whokeys.com in the video description below.
Okay, let's start then. So here we have the Asus ProArt B660 Creator motherboard. Feel free to check out the review of this motherboard on my channel. So I'm not going to go so much in depth in this, but I think this is an awesome motherboard for the 12th gen because it has a DDR4 rather than DDR5. So it can be very, very affordable when doing this. So because this build is focused on the photographers, I think there's some of the things here that I'm gonna talk you through as well. But if you're a photographer, this motherboard has quite a lot of features, like quite fast USB ports on the back over here, very fast USB-C front panel port. We have 3 M.2 slots, 2 of them PCIe 4.0 capable, full speeds. If you are a Creative Cloud user, you're gonna get 3 months for free with this motherboard, which is why this motherboard becomes very, very affordable in the competition. So let's start installing the CPU then, the 12700 that we did the review recently. So we're just gonna install that over here. So with the 12 cores over here, this is the best 12 core chip on the market over there, and in the Photoshop and Lightroom Classic, actually, both of these applications, it beats out the Ryzen 9 5900X. So if you haven't seen the review of this chip yet, feel free to check it out on my channel. Very, very impressive. But next off, the RAM. For RAM, we're using something from Kingston Fury Beast. This is RGB over here as well. It's gonna fit in nicely with our theme, and it is 64 gigabytes, and you can easily double it if you want to, but for photo editing, RAM capacity is very, very important, and to have a lot of it is very important as well. So especially if you have loads of different photos over there, you can easily max out in RAM. So 64 I think is very good spot. 128 gigabyte would be excellent. 32 gigabyte would be absolute minimum that you want to go for. Next off, our SSD, M.2 SSD, our OS drive. And for that, we're actually using something that I haven't personally recommended or used on the channel before, on the video. I've used them on my actual builds. I'm actually running one of these early versions of this drive in my build, but they are very, very expensive, and sometimes you think, is it really worth it? The Samsung 980 Pro drives, this is a 1 terabyte in size, and you can get this with a heatsink or without the heatsink. I've gone without the heatsink because our motherboard already has a heatsink, so I don't see a reason why I should pay extra for the heatsink, and most motherboards do have heatsink, so you don't really need the heatsink unless you really know a reason why you can't use the motherboard include the heatsink, so your motherboard doesn't have a heatsink, but most of the time you do. But the very interesting thing about these Samsung drives is that this is for people who really need the highest end reliability. And recently Beauty Systems actually released a report of what parts and components they use in their PC build rebuilds and how many of them are like breaking, or what's like the actual like, you know, fault rate and so on. And these Samsung SSDs came out like absolutely insane. I'm gonna leave some of the B-roll over here so you can check out what it is, but I think it was something like 2,000 of them they used, and then maybe one of them failed, or maybe none of them failed out of 2,000, which was very, very impressive. So if you do need like the reliability, I would highly recommend you go with these drives over here. So if that is an important thing for you, then definitely use those drives. And by the way, these drives are super, super fast, like 7,000 megabytes per second or something like that. So one more thing you need before we install the M.2, underneath the motherboard box, there is something like this over here. This is a little standoff, like a sticker over here that's gonna go in this spot over here, this little black rubber thing over there, because our SSD has the NAND flash drives, or the flash and controller, they're all on one side, which means that it might be like a little bit bendy, or it doesn't have proper support on the bottom. So we're gonna put this that little sticker goes on top there, and then our SSD goes in. But very important, do not install this if your SSD has the NAND flash on both sides of like the PCB. You'll very easily see like these black little blobs over here. If they're both sides, do not do this. But in our case, it's only on one side, which means now it's going to support the bottom very nicely. So it's not going to bend, it's much better. And we put the heatsink back on. Okay, let's put the motherboard on the side, because next up we're gonna start to install the cooling. And for the cooling, we are using the Castle EX 360mm AIO, which we have over here. And you're thinking, 360mm AIO, do you really need that? If you've seen the review of my 12700, then you know that it at full utilization, it can pull quite a lot of power through. And we want to make sure that this chip can run at full speeds all the time without any issues. So that's why we have this one over here. And this is a white version, which I think is going to look very, very interesting. You're going to see our whole thing is going to be a little bit of a black and white theme. So I'm interested to see how this is going to look like. But when you're buying your AIO with Deepcool or some other brands, make sure that you get the mounting bracket kit for the LGA 1700 socket over there as well, because it's a different socket, so we need that to, you know, get it properly installed. The cool thing with this mounting bracket is that there is actually some stickers over here, so you can kind of stick it on the back of this like metal plate over there, and it's gonna hold the back bracket in place, which is usually quite a nightmare with some of the other AIOs or some of the other mounting systems, that you have to hold it in place while screwing on the other side. Whereas this one, line up the screw holes over here and then stick it on. And as you can see, it's in place. It holds in there. Now our screw holes are nicely on this side. Before I'm actually gonna install the AIO, I wanna get my case out, because I wanna really prepare the case and really have a look like which orientation we're gonna put the AIO and so on. For the case, we're actually using something new from Deepcool as well. So this case is called, let me double check, CK560WH, which is a white version basically. There is a black version of this as well, but I wanted to go with the white because I think the white inside the black, it kind of has some kind of feel. Like my personal build over there is white as well, and black insides, like black components inside, but kind of a white case. It kind of makes like the inside a little bit lighter and it's easier to like look inside. But this one over here is like a white from the outside but black from the inside, which really fits our color theme with like what's going on, black and white, something like that. So this is a mid-tower case, and it looks very like a minimalistic type of very cool design. The front panel is like very meshed. Sides are open over here, and then this like plus design on the front over here. There's actually like air goes through as well, so that's that. It also comes with included 4 fans. 3 RGB on the front and then 1 black on the back. This one over here is a GPU SAC bracket actually built into the case, which is very nice thing to see. So we're gonna be mounting the radiator in the front over here, and we're gonna be using those included fans over here as well. So we're gonna be pulling like push and pull configuration for our radiator in the front, and then we're gonna have some extra fans on the top over here as well that we have over here. FC 120 white, so 3 performance ARGB fans, and they're going to be 2 on the top and then 1 in the back, kind of pushing it out. But we're going to be using the included fans inside the AIO to put it on the back of the AIO, and then these over there as well. So let's get working. Here's a little trick. If you don't have enough of those long screws like these, you know, to go through the fan and the frame and into the radiator, what you can do is you can actually cheat a little bit and not screw every single screw into the radiator. So because all of these included like fan screws were already screwed into there with those, you know, small fan screws, basically I just took one of them screws off, and then now I'm just gonna line it up with the radiator, and then I exchanged this screw over here with the long one, and then screwed the radiator in on the other one, whereas all the other ones are screwed into the fans over here. Then I did the same on the bottom over here, and then in the corner over here, and I'm actually gonna put just 4 screws on the top over here to hold this radiator in. This is not gonna go anywhere. Probably the best orientation to put the screws is like 1 on the bottom, 1 in the corner here, 1 in the middle here, and then 1 in the corner here, so it kind of equals evenly. And then all the other screws you can put on the other side, so it looks like you've got actually all of the fan screws on the other side on the radiator, rather than having just like, you know, diagonals or something like that. Also, halfway here through the installation, I realized that the push-pull configuration is really not going to work in this case, because this cutout for the radiator here isn't quite big enough. And this fan is not going to fit in there, but I'm completely fine with that, because I just want the top, you know, fans over here to create a little bit of an airflow over here, so we're not going to have negative airflow. But what I will configure is those exhaust fans to work slower than the intake fans over here, so that we have a positive pressure inside the case, which means our case is going to be less dusty, which means there's going to be no dust like pulled in from the backside over here, which is much nicer. So the way I want the AIO to go is like the tube scope on the top right over there, and then go on the left side of the AIO over here and kind of swizzle around. The reason I can't put tubes down is because the same reason I can then get the tubes up, but that's completely fine. If you want to have 360mm radiator, you have to install it in the front over here. If you want to have 280, that can go on the top over there, but not 360. So the interesting thing that I just realized is that the back fan is actually 140mm, not 120mm. As you can see, it's much bigger, which is nicer. If you want to have 140 in the back over here, you know, works quieter and so on, but we're going to put 120. Double check all the standoffs over here. The cool thing is 2 of the stand-offs over here are nubbins, so that's going to be great. But I'm going to turn this around on the side, because it's just going to be a little bit easier when mounting it like that. Okay, one thing I don't appreciate about this case is that all of the screws for this case is just in one pouch, completely like thrown in. So there's no separation really which case, like which screw is which. So I'm gonna have to like really find those screws inside the case or like the bag. It just would be easier if I had a few more bags, all them separately over there, rather than just like fishing for those screws in here. Now the cool thing about this mounting bracket is that the screws are already kind of attached to the like mounting bracket of the AIO, which is something new I haven't seen. Usually you have some kind of thumb screws and it's a little bit fiddly, but once I have screwed these in onto the AIO, it's going to be very easy. Now bear in mind, when you install those brackets over here, your thermal paste is going to be exposed, so be very careful not to ruin the thermal paste already that's applied. So now once the brackets have been installed on the AIO and the thermal paste has been pre-applied, it's very simple, just literally slotting it in there and then screwing those into the sockets. Okay, the AIO is installed, and the more and more and further I get with this build, like it gets nicer and nicer and nicer. Black and white, it kind of looks very, very nice here, okay? And the power supply is gonna actually fit into our theme as well, because it is a deep cool power supply. Now, this is a 1000 watt power supply and is a little bit of an overkill on this system, but this is just to show that if you wanted to get this system and build something very high end, you actually have a 1000 watt power supply that Deep Cool can provide you with this build. Now, this actually matches the design of the case and Deep Cool products, as well as something I really like and something I really haven't seen before is like the color of Deep Cool now seems to be like the brand color is like this teal or turquoise kind of color over here, and we have the same kind of label on the top cover over there. The top dust filter over there had the same color label over there, and I really like that. I think we might have the RGB match that, and all the casing, as you can see inside these like covers over there, it's the same color, so I like that a lot. But in the back you're gonna have this very, very nice type of thing. So we're gonna install it over there, obviously fan down because they can't really pull it inside the case, so they can pull cold air from there and then push it out there. So let's install the power supply and do some cable management. So one more thing about this power supply is that it is modular, as you can see over here, and it is 80+ gold certified, so very energy efficient as well. Another thing I want to mention, that if you want to have like a, you know, daisy chain the graphics card, then all the PCIe cables that come with the box are actually just one. There is no connection over there. There's just 8-pin. So if you need 3 8-pin over there, you're gonna have to run 3 cables, which actually is better and kind of helps you not to make the mistake that if you want to daisy chain, for example, an RTX 3090 that requires a lot of power, then it's not good to run them like from the same cable or have like two kind of slots on the graphics card from the same cable on the graphics card or from the power supply, because one of the cables is rated only at 150 watt power limit. So it's best to run 3 separate things. So in this case here, how many ports you have on your graphics card, you're gonna have to run them separately, which is a good thing, really. While I'm installing the power supply over here, I just want to talk about these drive bays over here as well. There are 2 drive bays that are kind of like a quick installation over here that you can install on the bottom over there. We're not gonna have any drives, so I'm gonna take them out, but you can install 2 drives over there. You do have a little bit like less space for your power supply when the drives are installed, but that's that. Then you have a few more like drive installation spots over here. These are for 2.5 inch drives over here. So you have like 2 2.5 inch drives and then 3.5 inch bays on the bottom over there. Thing about these fans are that these are like daisy chain, like kind of togetherable or daisy chainable, so you can literally just plug them in the back of each other because they've got these little slots over there. So the RGB and the actual fan, like, you know, PWM fan RPM signal both works on the same like headers, so that's going to be very, very cool. And then you connect the last header to like this cable over here, and then you're going to get SATA power to power all these things, then the PWM connector which goes to the motherboard, and then RGB connector over here that goes to the motherboard over there. And you can actually like daisy chain them together, another RGB products into this one if you wanted to, because there's a male header over here as well. So let's get these installed. So in a moment we're going to complete the cable management, but the last thing we want to put in is the graphics card. And the graphics card we're going to be using in this build is an Asus RTX 3050. Now, why this card and this build, you know, such an overkill CPU and such an underkill, you know, GPU? But the thing is, if you are a photographer, and I've got this video on my channel, you know, before, I've made this before, you don't actually need a lot of graphics power. And even if you do a little bit of 4K editing, this card is perfect for that. But mainly if you want to run like, I don't know, many 4K monitors and things like that, you can run them off this card and, you know, it's going to do a great job. Most of the photo editing performance comes from the CPU, but this is just here if you need a little bit of video editing or so on to do. And it's the most affordable in the 30 series RTX NVIDIA graphics cards. So that's what we're going to be putting in here like that. It's nice and small, nice and cute, but powerful enough to do like light 4K editing and all the photo editing you need, because you don't need a lot of RTX or graphics power to do that. So for people who need that type of thing, I think this is an awesome pick. And that's why I think building your own is much better than having a pre-build, because pre-builds usually would have like a very low-end CPU, a very high-end GPU, because that's what you need for gaming really. But for creative purposes, it's kind of like the other way around, especially if you're like on a budget side. You want to have something like this over here, and then very like high-end or as high of a CPU as you can, because most of it gets done on the CPU. But I think this looks very, very nice here. I'm going to continue with the cable management, get that sorted, and then soon we're going to turn this guy on. Okay, let's see if this bad boy turns on now. Let's hit the power button, see what happens. Okay. I mean, looks like we're on the boot window already, so that looks like this guy's working.
She at the back, bro.
Okay, look at this guy over here. Looks like it's working, everything's going. I can see new CPU installed and everything. Looks like this is all working over here. Now, next up, you know, let's do some configuration and then come back when it all looks nice and, you know, RGB is corrected and everything's installed and so on. So then the design, as you can see now, finally the RGB is configured. It looks very nice. We've got it all white. Now I decided to go white. I mean, you could go a different color as well with the RGB, but like another color that could really work really well is like this kind of teal color that is in like this theme. You've got the power button on the back of the PSU and the top panel over there here as well, this kind of tealish color. So if you want to put the RGB that color, that could work really well as well. But I think this is a very unique case, because I haven't seen a lot of cases that are kind of like a black and white color theme. The inside of this is black, as you can see over here, but like all the outside is white. I've got the, you know, glass open at the moment, but if you had the glass on, you'd kind of have the glass frame on it as well, which is very interesting and cool and different if you want to have kind of like a black components inside, but kind of have the PC looking white at the same time. I haven't seen a lot of these, but I very much like it. The PC design is very interesting as well, because there's a lot of airflow from the front over here. There is like a panel over here with these plus signs, or like little X's over on the front over here. So it kind of goes through. There's big caps on the side. This panel comes off, and underneath or behind there is a front mesh panel. And then you've got just very good airflow going through, like no problem in terms of airflow. Another thing is they have used different materials in this case. This one over here is metal, but then like the front like kind of frame over here is plastic. Then the top, you know, all the sides, everything else is kind of metal, but just this front frame around it is plastic. But interestingly, the color actually matches very well. Usually when you have like plastics and metal matching, you can't really match the white color very well, but in here it matches very, very well. You can see that they've really thought about the symmetry of things. And on the top, if you look at the buttons that I've included on top of the case, there is two USB type A ports, the USB 3.0 speed, so depending on your motherboard headers, you know, you can get 5 or 10 gigabits, and USB-C port as well. Now, our USB port over here is super fast because of this motherboard. It's 20 gigabits in speed, and it can also deliver 60 watts of charging, which is pretty cool as well. But there's like a symmetry over here that the headphone jack is in the middle, then you've got these two like USB type A buttons, and then power and LED button, and then the USB type C and the LED on the other side. Kind of, it's just like a nice symmetry. They've really thought about the design, and I really appreciate that. Another thing cool about this case and design is that if you're running a bigger GPU and if you want to use this case for maybe some video editing or some higher end GPU hardware, then GPU SAC bracket has been built into the case, which it's just absolutely fantastic. You don't have to have another little thing or kind of fiddle around, because this just fits with the case and all this. I'm very happy about that. So then let's have a look at some of the benchmarks of this PC. First of all, the SSD benchmark over here, which is the, you know, Samsung 980 Pro, and I ran the Crystal Disk Mark 1 GB test over here for sequential read and write and random read and writes. You can see that the read speed is like around 7,000 megabytes per second. Write speeds roughly around 5,000 megabytes per second. So super fast speeds over there, like nothing, you know, to complain about. Anything else in that, you know, region kind of is just, we're just splitting hairs, you know, in terms of, okay, which is better, which is worse. So the next thing I want to do is run Cinebench R23 test, and this is the multi-core test over here. And this will show us like how good is the cooling of the CPU and how does the system perform over here. So as you can see, we're pulling 180 watts from the socket at the moment, which is quite a lot for anything really out there. But also, as you can see, our 360mm AIO is roughly around 85, like in the low 80 kind of degrees. As you can see, 23 degrees ambient temperature. So I think the cooling is doing pretty good job. Let's put the side panel on to see if that makes any difference over here. Sometimes putting a side panel on actually makes it better, because the actual air is not being pulled, like kind of pushed out from the case, but actually pulled inside the case and then out, and it's kind of a better like tunnel way this way. But as you can see, because this is a 12700, which means that our like boost clocks only have a limited time over here. Now it's running roughly around 65 watt TDP, as you can see, and it's not boosting into those high clock speeds anymore because the load on the CPU is lower. So if I stop this test over here, and then if I started this again, you can see that we're still pulling about 180 now watts from the socket. Oh, interestingly, this time it actually pulled less time on there, which is interesting. Now, when we're idling over here, this is the interesting thing and the amazing thing about the Intel CPUs or the 12th gen CPUs over here. The idle like wattage over here is about 8 or 7 watts, which is just insane. Like compared to the Ryzen systems, it's like 5 or even 4 or 5 times less. Ryzen systems like idle between 30 to 40 watts, something around there. And look at this one over here. The minimum has been 7 watts, you know, roughly around 88 watts over there. Amazing. So is this AIO good for this type of system, 360 millimeters? I'd say it's pretty good over here. Look at this, 180 watts now pulled from the socket, and we're like in the low 80s. Now this is way below the CPU like maximum temperature, so it's not throttling this system. It might be a little bit louder over here. I would advise you to put the actual CPU pump like always 100% or something like that, then it would be much better temperatures. In terms of the core clock speeds, as you can see, only one core is roughly close to 4.9 gigahertz over here. The others are 4.8, the performance cores, and the efficiency cores over here are 3.6 gigahertz maximum boost clocks. So in terms of photo editing benchmarks over here, first of all, let's have a look at the Photoshop benchmark over here. As you can see on the right side over here, I've got my calculated benchmarks over here, and we've done the average over here, and we're roughly scoring 1170 on the Photoshop over here. And then looking on my like benchmark database over here, I can see that we're scoring roughly around here, which is Like 12600K over here is slightly lower. That's best bang for buck. That's this white PC that we built it over there with 3060, so much better GPU over there. But let's have a look at some of the other PCs. This is the Vitamin C that is with RTX 3070 and Ryzen 9 5900X, so 12 cores as well. And as you can see, we're literally performing within the same margin over there, but our system is much cheaper. The CPU is cheaper, the GPU is cheaper, but we're performing in the same ballpark. But as you can see, some of these scores can be even above that, which means we're faster than the Ryzen 9 5900X and RTX 3070. And this 3050 is a much less powerful card than RTX 3070. Now moving on to Lightroom Classic benchmark over here, we've scored 1233 in average. But as you can see, I've had one very bad score down here, and we're roughly around 1252 or 1240, something like around there, which really scores us like kind of just below this 12600K test bench over here. This is with DDR5, so DDR5 really kind of helps you with that, but we are running DDR4, very kind of cheap DDR4, so I'm super happy with that performance really. Bear in mind, we're still better than the Vitamin C build, which is Ryzen 5900X and RTX 3070. And finally, let's have a look at video editing benchmark. This over here is the Budget Bench Premiere Pro benchmark. And as you can see, the standard overall score is 957. And if you're thinking, so where does this kind of slot into and how does this work? Then the actual benchmark standard score, like a 1000 overall score and then 100 on all of these like lower scores, has been made with an RTX 3080 and the 5900X with 64 gigabytes of RAM as well. So very high-end system, as you can see, for Premiere Pro. But look at this one. Our standard live playback score is 41% better than the RTX 3080 with Ryzen 5900X. That's insane. So if you're doing like any H.264, H.265 kind of editing in your workflow, even if you're a photographer, then this system absolutely is amazing for doing something like that. Even the extended live playback score is very much higher than the reference system over there. The standard export score and extended export score, as well as the GPU and CPU FX scores, are a little bit lower just because some of the other components over here aren't as powerful, especially GPU, but still only 35% slower. I think whatever little video editing you're going to be doing, this is absolutely fine for you. So my final thoughts about this PC is, I think it looks absolutely fantastic. And if you're a photographer who looks for something that is kind of affordable and just gets a lot of, good work done, then this is the build for you. If you're wondering like, oh, what are some of the tweaks I could do to maybe optimize my performance even more for my workflow, then I would recommend maybe looking into the 12700K, the K version, which can boost all the time to that 180 watts and is not as kind of reserved in the TDP, but just able to do that. So it is a little bit faster, so I would recommend checking that out if you want to. But you can put any chip in here all the way up to 12900K if you wanted to. Also upgrading the RAM to double these sticks that what I have over there, just literally have double the amount, put them next to it, and then you have 128 gigabytes, no problem over there. Let's not say over there. And another thing I would recommend you to do is get a few more SSDs, like for the second slot over there, the PCIe 4th gen slot. Get another Samsung SSD, for example, or 2 terabyte, or a bit higher, where you can have your projects on or something like that. And then you have still one spare PCIe Gen 3 slot over there for some other drives that you might have. So I'd really kind of optimize and take advantage of those slots and put some of the SSDs in there. I'm going to leave all the components in here, as well as some of the recommendations here in the description below. As always guys, I'd be curious to know what you guys think. Let me know in the comment section below. Thanks guys for watching. Likes if you enjoyed it, subs if you'd like to see more, and I'll see you next time. Bye bye.